All right, now let's continue to talk about graphing techniques transformation. So there are total 3 different types of graphing transformation techniques. Okay, first one is called a shift. Second one is called a stretch compress or compress stretch. Okay, the order doesn't matter. And then the third one is called a reflection. All right, so you may wonder, how can I tell which transformation techniques has been applied, right? Or tells you the transformation technician and what kind of changes to the function, right? Those are the very common questions, and then that's make most students very confused. So I want you to remember, those principles first, okay? Which is what transformation techniques need to apply. Okay, so shift is the key function, either adding or subtracting a number. Okay, we call that constant. Okay, so whenever related to the shifting, is always about adding or subtracting a constant. Okay, that's about shifting. Okay, stretch compress. Okay, that's always related to multiply or divide a number. We call it constant. Okay, multiply or divide constant. Any number will be fine. And then the third one, reflection, is also multiply. Okay, but not multiply by any number. It's multiplied by a specific number, which is multiplied by 91 only. Either x times 91 or y times 91. Okay, here y is the same as f of x. Okay, so those are the principles. If you can remember those, and at least what transformation techniques you need to use is clear. Okay, shift is adding, subtracting a constant. Stretch compress is multiply or divide a constant. And then reflection is either x times 91 or y times 91. All right, so remember that. Okay, and then the details, we're gonna look at it one by one. So first we look at shifts. Okay, so when we talk about a shift, there are 4 different directions we can do the shift, right? One is shifting up or shifting down, either shifting up, right, or shifting down. That's in the vertical direction. Okay, we call this 2 direction is the vertical. And then either shifting to the left or shifting to the right. So those 2 we call the horizontal direction. Right? When we do the shift, only these 4 basic directions. So you say, what if I want to shift from here to here? Right? If this is the first location, this is the second location. And then, you can break it up to the 2 shift, right? You can either up first and then right to get here. Okay, or you can shift right first and then up. Okay, so any other position you can always break as those 4 basic shifts, right? So that's why we only need to learn the basic 4 shifting techniques, and then any other position you can, breaking those from those basic 4 shifts. So earlier we talked about vertical direction, horizontal direction. Okay, so think about in a rectangular coordinate system, what coordinates controls in the vertical direction? That will be the y coordinates, right? So vertical direction shift is always associated as the y change. Okay, y here is the same as f of x. Okay, I'm emphasizing all the time. And horizontal direction, what coordinates controls horizontal direction as x changes, right? So remember that. And then we're going to talk about what is y change, what is the x change, okay? All right, now let's look at this example. F of x equals x squared, and then g of x equals x squared plus 3, right? So now x squared we know is f of x. So can we rewrite g of x as f of x plus 3? Can we do that? Right? Because we know f of x equals x squared. That's why we just replace x squared by f of x. So in other words, g of x equals f of x plus 3. So what is f of x? F of x is a y, right? So that's why it's y plus 3, right? Y change, y plus 3. And then, first of all, plus or minus, we know the transformation is a shift. And then plus 3, y plus 3, right? Y change. So y change, that means is in the vertical direction. Right? It's a vertical direction shift. And then vertical direction shift only either up or down, right? So positive number, so vertically shift up 3. Okay, up 3. So that's how we analyze this the transformation techniques here. Okay, first determine what transformation applied. So adding, subtracting is a shift. Second, we want to know what direction shift. Okay, so check whether it's an x change or y change. Right? That determines the direction, either horizontal direction or vertical direction. And then if it's a y change, in this case, and a vertical direction, and then plus is up, minus is down. Okay, that's the 3 steps we can easily analyze how to, graph function g of x. Okay, so f of x equals x squared square function. That's the key function in our library. And then we know what's the graph look like, right? It's a parabola. And then in order to find a graph of g of x, we need to vertically, okay, shift up 3 units. Okay, so 1, 2, 3. So now we imagine x-axis, okay, shifting here, vertically shifting up 3 units, and then the corresponding parabola vertically shifting up 3 units. Okay, so all the shape, everything remain the same. You only imagine we lift this parabola and x-axis straight up 3 units. That's how to get the new graph for g of x. This is graph of f of x. This one is a graph for g of x. All right. And then how to find the domain and the range. So we know this is the y change, right? In this case, we already figured out it's the y change. Y change, that means x remain the same, right? So originally, square function, the x, which is a domain, right? It's all real numbers, right? So the new function g of x doesn't change, so still all real numbers. Okay, what about the range? Range, y change, right? So does change. Original is square function is 0 to positive infinity. So after shifting up 3 units, so now you can see the lowest points on the parabola is positive 3, right? So that's 3 to positive infinity. That is the range. All right, so now let's look at another example. This is just to explain what I just showed you. Okay, that's the better graph. Okay, this is a function f of x. This is vertically shifting up. That's the g of x. All right, so let's try another one. We still use f of x, okay, as the original function. f of x equals x squared, and then we try to get a graph of g of x, which is x squared minus 4. All right, so again, we can rewrite x squared minus 4 as f of x, right? X squared, that's the f of x minus 4. Okay, so this is a y, right? Y change. Okay, so first we determine it's a y change. And then what kind of change? Minus 4 plus minus. So transformation technique is a shift, right? Y change, that means vertical direction, right? Vertical direction. And then how much vertical direction shift? Minus a constant, right? Minus constant. So vertically shifting down. How many units? 4 units. That's how we figure out the transformation techniques. Okay, and then graph. Again, square function. Okay, the parabola and the vertex is right at the origin 0, 0, right? And then vertically shifting down. So this is the new x-axis. Is imagine, okay? And then this is the graph. Okay, just drag this whole parabola vertically shifting down. Everything else remain the same, just a position change. Okay. So what about the domain and range? Again, y change, x remain the same. So domain will remain the same as original key function, which is from negative infinity to positive infinity. The range, y change, right? So range also change. So what is the lowest point in this case? Lowest point is negative 4, right? No longer 0 anymore. So it's from negative 4 to positive infinity. Okay, that's how we figure out the domain and range. That's the explanation. Okay, that's the better graph. My hand graph is not accurate. Original function, standard parabola, and then the new functions graph, vertically shifting down 4 units. All right. And you can also use your graphic calculator to graph all these 3 functions together. Okay, you use the key y equals defined function, right? In y1, you define as x squared. In y2, you define as x squared plus 2. y3, x squared minus 2. And then you click the key graph, okay? If you doesn't see anything, make sure you adjust the window size, okay? Adjust the window, maybe set x minimum to negative number, maybe negative 5, negative 10, whatever, okay? Or here, negative 6. X maximum is positive 10 because we know square function is trigonometric, and then the vertex is origin 0, 0. And then y minimum, you know, smallest is minus 2, right? You can set negative 5. Y maximum can set a little bit bigger number, let's say positive 10, and then you can see the graph like that, similar, okay? So here we have a summarize, okay? If we assume k is a positive number, and then if the key function y equals f of x, okay, and then we know the graph of this key function, and then the graph of a new function y equals fx plus k. Remember, k is a positive number, and then is the graph of f of x shift vertically up k units. Okay, similarly, if k is a still positive number, if we know the graph of y equals f of x, and then the graph for new function y equals f of x minus k is the graph of function f of x shift vertically down k units. Okay, or we can write it together, y equals f of x. Okay, we know this function's graph, and the new function's graph y equals f of x plus k. Okay, you can just summarize if K is a positive and then vertically shifting up, K is a negative, vertically shifting down. Let's combine the two together. Okay, instead of saying K must be positive and then plus is up, minus is down. Well, it's the same. Okay, just trying to make it easier. So up to you. Okay, if you memorize these two together, that's fine. Or you memorize these two individually, that's fine too. Okay, that's all about shift.